You're welcome, function folks. This is lesson 1.5b, graphing by factoring, which is another little bit from this chapter. Didn't fit in with yesterday's huge, or last day's huge lesson, so hopefully this one's a little bit of a shorter video day, and you can sort of get caught up with some old homework maybe. The 3-minute review, typical one from what we've been doing. We see this is a degree 4. 1, 2, 3, 4. It starts low and ends, well, starts high rather and ends high because it's a quartic, degree 4, and the leading coefficient is positive 1. And then the x-intercepts I can see are -1. 3 is a double or a bounce root, double root, and x equals 6. And so I'm going to put those zeros in, the big obvious dots. 3, 4, 5, 6, there we go. And starts high and ends high. And slash, bounce, slash, right? So I go slash, bounce, slash, and I get something that looks like that. I'm going to want to calculate a point to put some scale on here. The y-intercept hopefully is going to be a negative number, and what do I got? I got 1, 0 plus 1 is 1, minus 3 squared times minus 6. 9 times minus 6 is negative 54, dandy. Minus 54. That's it for the 3-minute review, exactly what we've been seeing. Now, the big question that we're actually going to spend several days answering this question is, what happens if the function isn't in factored form? You know, we could do a pretty good job with the graph if it was in this factored form, but what happens if it's not factored? There's the phone, pause. And apparently I have a dentist appointment tomorrow, and that's what that was all about. Now, where were we? Okay, yeah, right. If it's not in factored form, like in this one, these ones here, you know, we can know that it's a cubic and it starts low and ends high, but all the details in the middle are lost. We got that from the factored form. So if it's not factored, what do we do? Well, what do you think? Yep, good old factoring. We're going to be practicing our grade 11 skills today. We're going to try and put these things in factored form. So for instance here, well, what do we do first? We always think of the common factor first. And I see a common factor of x. And then this is a easy quadratic. Numbers that multiply to get -6 and add to get -5 are nope, not -3 and -2. That would be +6. -6 and +1. And then I can graph that quickly, and I'm going to. So I have an x-intercept of 0, and I know I should be writing in all the details, but you're probably getting pretty tired of having to do all this stuff, and we get the picture, but we'll maybe practice the graphs a little bit here as well. Starts low, ends high, all of them slash roots. A point. We already have the y-intercept, so we'll try some other point. Maybe x is 2, y is, well, and I can either substitute in this version or the factored version. I'm hoping that I'll be able to do the factored version in my head. 2 times -4 times 3 is -24. So, and does that make sense? Would that look like -24? Sure, I guess. Dandy. And this is the skill, the factoring, grade 11 factoring skill that we used here was just good old common factoring. You see, in the second one, there isn't a common factor, right? But we see something's going on. It looks like there's the first part, there's a common factor, and the second part, there's a common factor. And in fact, that's what we're going to do. This is a factoring technique that you learned in grade 11 called grouping. We're going to factor the first group. Well, there's a common factor of x squared in the first group, and a common factor, and I'm going to use -9. I'm going to use minus 9 as the factor from the second group, and I'll show you why. That's because now when I factor the second group here, and the negative 9 comes out of here, then I have the same bracket. And it itself then is the common factor, right? This is the common factor in the bracket. So I'm going to common factor the bracket out and think about, well, what's left? When I take the bracket out of this first term, I'm left with the x squared term. When I take the bracket out of this second term, I'm left with the minus 9. And then this thing can be factored again. This thing is a difference of squares. Right? Difference of squares, x minus 3 and x plus 3. And I see that it's a cubic. Zeros are at 1, minus 3, and 3. Now it starts low and ends low because it's got a leading coefficient that's positive. All of them are slash roots. Awesome. Just like that. I'm going to use, for my scale, my x-intercept, which is actually 9, isn't it? Because 0, 0, 0, then there's my y-intercept, rather, and that's 9 right there. There's my scale. Dandy. Zooming right along. Now this next one, the no common factors, won't factor by grouping. Grouping works with a special kind that's 4 terms, and this one's not 4 terms. But you see how this is, and I'm going to change color here because we're kind of going to take a little bit of a detour on this one. Because what this one kind of looks like, I should have put the cloud around it after, but this kind of looks like this expression, right? Where this is easy to factor. This isn't so bad at all. Where, where I'd normally have just a normal variable a, I use capital A here just for funsies, I have an x squared, and this first term is that thing, a squared, right? So here, I'm kind of letting, if capital A takes the place of x squared, then I can factor this grade 10 style. It's just minus 4 and minus 1, right? Well, the thing is my expression here didn't have an a, it had an x squared. So how would I factor that? This becomes x squared minus 4 and x squared minus 1, right? In the place of the a, I have the x squared. And now that's factored, and I can see that it's still going to be a quartic, and these are 2 difference of squares here, right? This is factors further. X minus 2, x plus 2, x minus 1, x plus 1. And now I know it's a quartic, starts high, ends high, and all my zeros, I've got 2 and minus 2 and 1 and minus 1, and all of them are slash roots. Oops. That's not so bad. And of course, my single point that I want to use for scale, I'm going to use the y-intercept, which is 4. So that point right there should be 4. This technique, we'll often use this. We could think of it as the problem-solving technique, solve a simpler problem, right? If we just thought of this in a different way, it was a simple problem. But this factoring technique is called quadratic form, because this has quadratic form. It kind of looks like a quadratic if we think of it in the right way. So it's called quadratic form. That was the technique. Dandy. So our factoring techniques from grade 11 have helped us graph these ones that weren't in factored form yet. And of course, the next thing is that you might think about, well, what happens if one of these 3 techniques doesn't work? Like if I can't, it's not quadratic form, and it's not grouping, and it's not a common factor, well, then what do we do? Well, we spend more time learning more fun math. But that's it for today. There's your homework, is actually to do these ones. I'll post the solutions on the Facebook or at the back of the room but that's what we'll deal with today. It's not a full period's worth of work, so you can either finish up old stuff or get started on the next thing. That is up to you.